Hello guys, today class we will see some more problems. So a balanced delta connected load with a per phase impedance of 12 plus J9 ohms. So he has given the per phase impedance as 2 plus J9 ohms which is connected in delta, and the voltage he has given as 400 volts and 50 hertz 3 phase source, and he asked to calculate the phase voltage, line voltage as well as currents in each phase. So first we will draw the phasor diagram. So first 12 plus J9 ohms, no? So it is connected in delta, no? So I am drawing 12 plus J9 ohms, 12 plus J9 ohms which is connected in delta. So I am drawing it 12 plus J9 in R phase and B phase as well as Y phase. 12 plus J9 ohms. J9 ohms. So it is connected in delta. So I am naming it every phase. So R, B as well as Y phase. So it is connected here. This is Y phase. So R phase and Y phase and B phase. So for this, if current flows through R, so I can name it as IR, line current. If a current flows through Y, I am naming it as IY, and B phase IB. These are the line currents, and phase currents are IRY, IYB and IBR. These are phase currents. So we have to calculate the phase voltage, line voltage as well as currents. So first we will write the given data for this circuit. So he has given that voltage is 400 volts, no? So as you know, for three phase they are separated by 120 degrees. So VRY equal to 400 volts at an angle of 0, and YB equal to 400 at an angle of, we can write 400 at an angle of minus 120 degrees, and VBR equal to 400 at an angle of plus 120 degrees, So these are the three phase voltages VRY, VYB and VBR. As you know, I will write a statement as it is delta connected load, as it is delta connected load. So as it is delta connected load, as you know, for delta connected load the phase voltage and line voltage are equal, no? So phase voltage is equal to line voltage in case of delta connection. So in case of delta connection the phase voltage is equal to line voltage. So we have determined the phase voltage and line voltage. Next we have to calculate the currents. So for first current IRY, as you know, current is the ratio of voltage by impedance, no? So VRY by impedance Z. So VRY, the voltage across VRY value is 400 at an angle of 0 by impedance. Impedance for the total three phases, no? So for three phases, if you calculate it in the polar form, the value will be 15 at an angle of 36.86 degrees. 36.86 degrees is the impedance. So it is in the form of R1 by R2, theta 1 by theta 2. So the value of IRY equal to 400 by 15. 400 by 15, the value will be 26.66 at an angle of minus 36.86 amperes. 36.86 amperes. This is in polar form. If you convert it into rectangular form, the value will be 21.33 minus J value 15.99 ampere. 15.99 ampere. This is the current IRY. This is the first current. So we have to calculate the IYB and IBR also, no? So IYB equal to 400 at an angle of minus 120, 400 at an angle of minus 120 by the value of impedance 15 at an angle of 36.86 degrees. 36.86 degrees. It is also in the form of R1 theta 1, R1 R2 theta 2. So R1 by R2 theta 1 minus theta 2. So 400 by 15, the value will be 26.66, 26.66, and theta 1 minus theta 2. So theta 1 minus theta 2, the value will be minus 156.86 amperes. It is in polar form. IYB in polar form. So if you convert it into rectangular form, IYB equal to minus 24.51 minus J 10.47 ampere. 10.47 ampere. This is the IYB. And the last value is IBR. So IBR value equal to VBR, voltage across BR by impedance. So voltage across BR means 400 at an angle of minus 120 by impedance value. Impedance value, as you know, 15 at an angle of 36.86 degrees. 36.86 degrees. So IBR equal to 26.66 at an angle of 83.14 ampere. It is in polar form. So we want in rectangular form. So IBR in rectangular form will be 3.18 plus J 26.46 ampere. It is in rectangular form. So we have calculated the currents, all the three currents. Next, line current. So for line current, IR equal to IRY minus IBR. IRY minus IBR. So for this IRY, as you know, IRY value is 21.33 minus J 15.99 minus BR. IBR value is 3.18 plus J 26.46. So the IR value, line current value will be 18.15 minus J 42.45 amperes. This is the IR value. Similarly, we have to calculate another two line currents. IY equal to IYB minus IRY. As you know, IYB value is minus 24.51 minus J 10.47 minus IRY value is 21.33 minus J 15.99. So the value of IYB minus IRY value will be minus 45.84 plus J 5.52 amperes. So this is the IY value. So I am naming it as a fourth equation, and this is fifth equation, and last equation is IB. This is the last current, line current. So IB is IBR minus IYB. IBR value, as you know, IBR value is 3.18 plus J 26.46 and IYB value is minus 24.51 minus J 10.47, 10.47. So the value of IB value will be IBR minus IYB, no? So the value will be 27.69, 27.69 plus J 36.93, 36.93 amperes. This is the sixth equation. This is the IB value. So we have calculated the phase currents as well as line currents, and he also asked to calculate the voltages. So we have determined the phase voltage, line voltage. So in delta connection, phase voltage and line voltage is equal. So we have calculated the three values. Phase and line voltages are 400 at an angle 0, 400 at an angle of minus 120, 400 at an angle of plus 120. These are the phase and line voltages. Next we have to calculate the currents. Currents are two types, no, line currents and phase currents. So first we have calculated the phase currents, IRY, IYB and IBR. These are the phase currents. And next we have calculated the line currents. Line currents are IR as well as IY and IB. So we have calculated all those terms, currents as well as voltages for the delta connected load. Thank you guys. We will meet in next class. Thank you.